Right, now that we've studied many exponent rules, what we're going to be doing is putting it all together. So at the end of this lesson, you'll be able to use multiple exponent rules to simplify expressions. So we're just going to try, it says to simplify each expression using multiple exponent rules. There should be no negative exponents in your answer. So we definitely will have to use more than one rule to get our answer on these ones. All right, so first one, we're going to start out a little bit simple here. So first of all, if I have 3 to the negative 5 to the second, the first thing we need to do when we have a power to a power is multiply our exponents. When we have parentheses. When we have parentheses, we will, I'm just going to write up here, when we have parentheses, we will multiply. When we have multiplication, we will add. And when we have division, we will subtract, just to keep that in mind. All right, so here we're going to multiply. We're going to get 3 to the negative 10. And then it says there should be no negative exponents. So we know to rewrite this with a positive exponent, this is going to end up being 1 over 3 to the positive 10. All right, example 8, we have m to the negative 3 times m to the 3. I know that if I have multiplication, we get to add our exponents. So negative 3 plus 3 will be 0, so I get m to the 0. And then I get to use the property that says anything raised to the 0 power will be 1. So my answer will be 1. All right, problem 9. Let's do 4x to the 10 times 7x to the negative 12, we'll do negative 12. All right, so we've got this going on. If you recall, with the normal numbers, just multiply the normal numbers. So 4 times 7 will be 28. And then when we have multiplication with like bases, we add the exponents. So 10 plus negative 12 will be negative 2. So get 28x to the negative 2. So that was one property. And then our other property is we're not allowed to have negative exponents. So to make this positive, we can move it down to the denominator of the fraction. So we'll have 28 over x to the positive 2. And that will be my answer. Okay, number 10, we have x to the 4 times x to the 3 over x to the 11. What we're going to do on this one is, first of all, let's tackle the multiplication part of this. If there's multiplication, we know we get to add our exponents. So we'll get x to the 7 over x to the 11. And then if I have division, I know I get to subtract my exponents. So 7 minus 11 will be negative 4, so I'll get x to the negative 4. And then we get to use another rule, because we're not allowed to have negative exponents, so rewriting this, it would be 1 over x to the positive 4. All right, let's try 11. Here we go. 5m to the negative 3. N squared. Actually, there's only one where we get to use on this one, and that is just we can't combine anything because they're different bases, but we're not allowed to have negative exponents. So we just need to move this specific part only into the denominator. So the 5 and the n squared are going to stay up top, and m moves down to the bottom, and it becomes a positive 3, and that is it. All right, number 12, we're going to have x to the 8 squared times x to the 3rd. Okay, so the first thing that we want to do is tackle those parentheses. I know when I have parentheses, we're going to multiply the exponents. So I'm going to get x to the 16th times x to the 3rd. And then I know when I have multiplication of like bases, we'll add the exponents. So 16 plus 3 will be 19. So my answer will be x to the 19th. Okay, problem 13. Let's have 3x to the negative 2 over 2x to the 5th, and let's raise that whole entire expression to the 3rd power. All right, first thing that I like to do is put 1s on any numbers that don't have exponents on them. And then if you remember, when we have parentheses, we're going to multiply the exponents. So I'll have 3 to the 1 times 3 is 3. X to the negative 2 times 3 is negative 6. Then down below, 2 to the 1 times 3 is 3. And x to the 5 times 3 is 15. All right, from here, the next thing that I'm actually going to do is figure out what these numbers are before I even try anything else. 3 to the 3rd will be 27, and then 2 to the 3rd is 8. Okay, and then the next thing that I am going to do is we need to, if we have division, we get to subtract our exponents. I'm not going to do anything with that 27 and the 8 right now because it doesn't reduce and they're just numbers, so I don't need to do anything with them. But then if I do negative 6 minus 15, I'll get x to the negative 21. And then since this is a negative, it belongs down on the bottom with the 8. So my final answer will be 27 over 8x to the 21st power. Okay, next one, let's see if we can get super complicated here. X to the 2nd, y to the negative 3 over x to the 5th, y to the 10th, and then we're going to raise that to the second power. And I'm going to show you two different ways of doing this, and you can pick your favorite. I'll show you, start with my favorite. The way that I like to do it is start with the division inside by subtracting my exponents. So I'm going to get x. 2 minus 5 is negative 3. And then negative 3 minus 10 will be y to the negative 13. And then this is still raised to the second power. And then from there, what? Did I do something wrong there? Yes, I did. No, I didn't. We're good. And then from here, we will have x to the negative 6, and then we will have y to the negative 26 because I'm multiplying my exponents, and they're both negative, so they both belong on the bottom. So it will be 1 over x to the 6, y to the 26. All right, so that was one way of working the problem. The other way of working the problem would be to get rid of the parentheses first by multiplying. So I would have gotten x to the 4, y to the negative 6, and then x to the 10, y to the 20. All right, and then what I would have done from there, since I have my division, now we'd subtract. And notice when I subtract, 4 minus 10 is negative 6, and then negative 6 minus 20 is negative 26, and I get the exact same answer that I did up there. So you decide which way you like the best. All right, problem 15, a couple more here. Let's say I have x to the 3rd, y to the 4th, over x, y to the 7th, times x, y to the 8th, over x squared, y squared. All right, again, I'm going to do this two different ways, and I would like you to pick your favorite way. First thing that I'm going to do, though, is anything that doesn't have a power on it, I'm going to put a 1 so I don't forget about it. Okay, first way, and this is personally my favorite way, but it doesn't matter. I am going to look at the divide signs, and I'm going to subtract. So x, 3 minus 1 will be 2. And then 4 minus 7 will be negative 3. Then bring down that times sign. And then with my x's, 1 minus 2 will be negative 1. And then with my y's, 8 minus 2 will be 6. All right, and then from here, if I have multiplication, I know I get to add the exponents. So 2 plus negative 1 will be 1. And then y, negative 3 plus 6 will be 3. So that would be my answer. All right, a second way that you could work this, though, I could do the multiplication first. So I could go across up top and add my exponents. So I get x to the 4, y to the 12. And then on the denominator, I would get x to the 3, y to the 9. And then from here, since I have my division, I'd subtract. 4 minus 3 would be x to the 1. And if I subtract 12 minus 9 would be 3. So notice we get the same answer either way. Whichever way you're most comfortable with is the way that you should work it. All right, let's try to tackle one more here. Negative 3 x to the 2nd, y cubed, all raised to the 2nd power, and then times negative 2 x to the x, y to the 4th, all raised to the 3rd power. Okay, first thing that we want to do, if anything is missing an exponent, let's put a 1 on it. Now we're going to start with the parentheses separately. Okay, we're going to do some multiplying. Whoops, these ones need 1s on them as well. Sorry about that. Okay, first of all, I need to think about this. A negative raised to an even power is going to be a positive answer. So this is just going to be positive 3 to the 2nd because 1 times 2 is 2. We'll get x to the 4, y to the 6th. I just multiplied the exponents, and then times. On this one, if I take a negative to an odd power, that will give me a negative number. So it's going to be negative 2, and then multiply the exponents, 2 to the 3, x to the 3, y to the 12. All right, from here, I'm going to do a couple things. Let me just get rid of my powers on my numbers first. 3 to the 2nd will be 9, so this will be 9x to the 4, y to the 6, times negative 8, x to the 3, y to the 12. Right, now from here, you're going to multiply the normal numbers. So 9 times negative 8 will be negative 72. And then we get to add our exponents. So we'll get x to the 7, y to the 18th. And then that would be my answer. So hopefully now you're able to simplify expressions using all sorts of exponent rules.